channel, and today I'm going to be talking about natural language processing. So what is natural language processing? As the name suggests, natural language processing helps a machine actually understand human text and human speech. For example, if you were to talk to someone else, then you would talk in regular English or whatever language you speak, and you're going to be talking naturally. Kind of like that if you want to talk the same way to a machine, but the machine has to be able to understand it and do the task at hand. Secondly, the machine should also be able to understand what you're writing. For example, sometimes when you're typing a word, it gives a suggestion for the ending of the word. So for example, if you write, for example, ERA, then it could be erase, or so on and so forth. So it's just giving more suggestions. And that's based on natural language processing, because the computer actually realizes and understands how normal text and speech is used in the human language, and especially in English. So that's natural language processing. Let's take an example to understand why natural language processing is very important. So imagine that we have a robot, and we assign it an arbitrary number of tasks, but the robot has to do it in chronological order. So for example, we say, first, do this specific task. Second, do this specific task. Third, do this specific task. Fourth, do this specific task. And last, do this specific task. Well, if the machine doesn't understand anything we're typing in, or essentially speaking to the machine, then obviously we're going to end up in a total disaster, or the robot's just going to do nothing. On the other hand, if it does understand what we're telling it to do, but doesn't understand the chronological keywords, for example, first, second, third, last, and fourth, and so on and so forth, then it's essentially not going to be able to process it and just does the step in random orders, or just the order you gave it from. Okay, now that we've talked about why it's really important, since in that case, the robot wouldn't do anything or would cause a total mess, if the robot could understand how the English language works and how it can process the language of human speech and human text, we would have a very, very more efficient robot, and the world would be much more easier to essentially live in. Okay, now that we've talked about why the natural language processing is very, very important, let's look at control. So control is very, very important. So imagine that we have a manufactured robot that can only do one specific task. For example, clean the carpet, or so on and so forth. Then, if it can only clean the carpet, we can at least have some degree of freedom to say that, okay, clean the carpet in this specific area, or avoid this specific area, and so on and so forth. But we can't really do what we want with the robot. The robot is only made to do one task, clean the carpet or the floor, and we can only give instructions related to that, kind of like a boundary condition. So we don't have too much control. But imagine we had a robot, and this could be coming up in the future, that it looks like a human and can do human tasks, and we can ask it anything what to do. Well, one, we can just type in what it's supposed to do in chronological order, or just type in randomly, or we could just speak to it by saying, do this, blah, 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 and so on and so forth, or type it, do this, blah, 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 etc. So we can just do that. But if the robot doesn't understand and use natural language processing, it is likely that it probably won't understand what we're saying, and the robot will become very, very useless, unless we have to manually program what it's supposed to do. But as a society, we want to make things easier for us. This is another thing why natural language processing is very, very important in today's society, in today's world. Okay. Now let's look at the specific steps for decoding a piece of text. So first we have tokenization. Tokenization essentially splits a sentence into specific words or whatever you want, specific phrases or a paragraph in specific sentences, and so on and so forth. We call these tokens. So, for example, we can take the dog is running outside. Now, this is a sentence, but we can see that we can split this up into tokens. One token, another token, the third token, the fourth token, and the fifth token. So we essentially have 5 tokens over here. Okay, so that's essentially what a token is. We're splitting it up. Now let's look at the next process. This is called stemming. So what is stemming? So imagine that we take a word. For example, let's take the word running. As you may start to notice, we're using a lot of the grammar rules and a lot of the things you probably learned in English class. So if we have running over here, we can see that it has a suffix ing. Ing just technically means we're doing it right now, so right now. But what stemming is mainly focused on is that we have the word run. We can see that run is the most important because it's essentially the stem. With this stem, we can essentially find the meaning of the word. For example, running means to currently or presently run. But without the stem, which is run, we really wouldn't understand it. Now that we have looked at this, we can go to the next step, lemmatization. So lemmatization is kind of a different process. Imagine that we had a word, which consisted of another word inside it, but that word does not relate with the total word. So if we use the process of stemming, it would probably guess the wrong stem, which doesn't even relate to it. That's why lemmatization comes in handy. Imagine if we have the word erase. We have the word era in here, but era is not the root word. Erase means totally something else. And this is a good example. So if you look at this, lemmatization is just trying to look at the definition of the word and then try to find the root from that. Next, we have speech tagging. So speech tagging is relatively very important in the field of natural language processing. So if we consider the sentence earlier, the dog is running outside, then we can see, obviously, that dog is going to be the noun, running is going to be the verb, and so on and so forth, etc. So we can just label these tokens. So there are totally 5 tokens over here, each with a part of speech. And that's what speech tagging is. Part of speech, hence speech tagging. Lastly, we have name entity tagging. So what this is essentially doing is just splitting up the words and tokens into specific categories. For example, a person, a place, so on and so forth. So we can have a bigger perspective and all. So for example, if we consider a man, then he's probably a person. If we consider a place, it's the location. We're just splitting up into categories so that we can understand and generalize what each of these specifically mean. Okay, now that we have finished with all the steps, let's summarize. So we talked about what natural language processing is. And natural language processing is essentially the ability for a machine to understand human speech and human text. The next thing that we talked about was an example to illustrate how natural language processing is important. Because if we don't have natural language processing, robots cannot probably understand us. And the world is going to be very complicated. And it was better probably to not have robots in the first place. So that's why natural language processing is very important. After that, we talked about control and that we need natural language processing to have more control on a specific robot. For example, if the robot can do anything, we could have technically more control over the robot and tell what each of the tasks it could do. Lastly, we have the steps. Tokenization splits it into sentences, words, phrase, or passages, and so on and so forth. If you have like a very long book. Next, we have stemming. Stemming essentially just gets away the prefixes and suffixes and just finds the stem. Lemmatization essentially just takes the word And if it's very confusing, that stemming will be too different. It just takes the word and it just finds a definition and then finds a root word from that. Lastly, speech tagging gets all, essentially, the tokens a part of speech. And after that, we have name entity tagging. This just divides them into bigger categories so that we can have a bigger perspective. Now that we talked about that, we can make this video to an end. If you like this video, if you like this channel, please subscribe to learn more. Thank you.